Hi viewers, welcome to LMS Solution. Today we are going to see about regenerative braking in BLDC motor driven electric vehicle. Directly we are going to see about the Simulink model developed for that concept. So it consists of a battery, and then here we have buck converter, and this is nothing but voltage source inverter, and this is nothing but BLDC motor, and BLDC motor having Hall sensor, decoder and control logic for generating the pulse for this voltage source inverter, and also this Hall sensor decoding logic is combined with the braking and running concept. Here we are going to measure the speed of the BLDC motor, and then we're going to be compared with the reference speed command, and then it's going to be processed via PID controller. It's going to be generate a duty cycle, and then this duty cycle is processed via PWM generator, and then it's going to be used for drive the IGBT on that buck converter to control the speed of the VLTC. Here you can see that we are using a 6 series battery, 12 volt battery, and then rated capacity of the battery is 150 Ah, and then initial state of charge of battery is 50%, and then this is 500 watts VLDC motor, 500 watts 48 volt VLDC motor. This 72 volt is going to be converted into around 60 volt. That means we have to provide 48 volt supply for the BLDC motor. And then here we are using voltage source inverter here. This inverter going to be driven by Hall sensor control logic. And also here you can see here with the Hall decoder under and real signal generation for that voltage source inverter. And also here we are combining that concept of running and braking concept here to get the energy from BLDC motor during braking condition. That means during braking, the kinetic energy in this BLDC motor going to be fed back to the battery. For that, we are created this control logic. This logic used to run the motor, and then this logic used to for applying the braking concept. And then here we are applying that control logic for generating the pulse. It will generate 6 pulse. This 6 pulse going to be combined with the running command logic and braking command logic. This is going to be control the voltage source motor in order to running command as well as braking command. Here you can see here the running command. That means we are going to simulate this model up to 5 seconds. System going to be in the running mode. After 5 seconds, it goes to braking mode. For that, we are providing this control logic here. And also during braking, we need to generate some braking pulse. That pulse going to be generated based upon battery current. Here you get to measure that battery current and crosses via PA controller. And then based upon this PA controller output, we have to generate the pulse. This pulse is going to be combined with this running and braking command signal. This signal, that means the braking pulse going to be combined with this logic, all sensor decoder and to control logic to control this voltage source inverter during that braking condition. See here that the initially that means reference speed is maintained at 3000 RPM from 0 to 5 second. The speed of the build is motor maintained at 3000 RPM. So after that, just you have to apply that braking command. During that command, the energy will be flown from this BLDC motor and voltage source inverter, and then via this diode to the battery. Now we are going to simulate this model. You will get the detail about this. First, I am going to simulate this model. Then I am going to show you that the speed of the machine. Now you can see that the speed of the machine is maintained at 3000 RPM. This under running condition. Reference speed is 3000 RPM, and you can see the battery details here. Then here you can see the torque of the BLDC motor. This is the speed of the BLDC motor. This is voltage across the voltage source inverter. Now you can see that the braking will be applied at 5 seconds. Because of that, you can see that BLDC motor speed is reduced to 0. During that time, you can see that the torque of the BLDC motor goes to negative. This is known as that energy going to be used to charge the battery during that braking condition. Here you can see that I will zoom that energy during that break is fed back with the battery. Because of that, the current of the battery is goes to negative. So the current of the battery is goes to negative means that get the power from the BLDC motor during braking. Battery is charging. Because of this negative current, you can see the SOC of the battery. The SOC of the battery is increasing because of that regenerative energy. And also you can see the battery voltage. The battery voltage are going to be increases from 71.5 to 71.6. And during this braking, the energy in the build is motor in the form of kinetic energy that going to be transferred to the battery to charge for the short time. So this is the concept of regenerative braking in the BLDC motor for electric vehicle application. Thank you for watching our videos. Kindly subscribe our channel and also click bell icon for a notification about upcoming videos. Thank you once again.